Okay, so this is joint work with Shlomi, who is new here. So welcome him warmly, and Ronen and Guy. And we're basically going to use landmarks in partially observable contingent planning. So to summarize the main contributions of this talk before I go into details, I'm going to show you a technique for approximating landmarks in partially observable contingent planning, and it's going to be based on projections to classical planning. Then I'm going to show you a heuristic for contingent planning, which is based on these landmarks. And I'm going to show you an online planner, which is called the HCP for Heuristic Contingent Planner, which uses this landmark heuristic and classical planning projections and does very well in practice. So let's look at a contingent planning problem. This is the Wumpus problem. So we've got the agent here, and we've got one Wumpus which can be either here or here, another one can be here or here, and the agent wants to go home. So it goes here, and notice this is not an action, right? This is already a conformant plan, basically, right? It's a sequence of actions with no sensing. Then it goes here and it checks whether there is stench, okay? Because next to Wumpai there is stench. So if there's no stench, then it knows it's in one of these two belief states, and that's what happens when you go from PowerPoint to OpenOffice. I don't know what will happen next. Yeah. So then it goes up there. If there's no stench, it knows it's in this belief state. Yep. Yeah. If there was stench, it would have gone there, and our belief states go crazy. And this is a contingent plan, right? It's basically a big tree and some spinny belief states. Yes. Okay. And yeah. All right. Yeah. Okay. So what I'm going to show you now is a very basic planning, sensing, replanning algorithm for online contingent planning. And this underlies quite a few contingent planners. So first, if there is a conforming plan to the goal, just take that plan, you're fine. Yeah, I don't know what it says if the goal is a conforming plan. But if there is a conforming plan to the goal, problem solved, right? Otherwise, you want to choose a sensing action which tells you something new, okay? Then you're going to compute a conformant plan which enables you to apply that sensing action. You're going to sense the unknown proposition, update your belief state, and repeat. And what we're going to do here is basically implement these steps using projections and landmarks. So first, let me formulate the problem. The OpenOffice is messing things up. Yeah. This is empty. Raul, maybe we should switch to your computer?
Some problems, right?
Yeah, but it's better than nothing. Yes, if you can. Thanks, Wheeler.
Do you have a flash drive?
Yep. This is the second time this has happened to me.
Oh, goodness, the resolution is a little screwy, but
Oh, that's fine.
yeah, there's a drive, right?
Yep.
Oops.
Oh,
The video people are going to hate us.
yep. Sorry for all of you that are recording. Yep.
This thing right here?
HCP ICAPS, yep. Oh, real PowerPoint.
Yes.
Yay. Thanks, Wheeler.
Sure.
Okay, let's go through this again quickly. Yes. Okay, so a contingent planning problem contains a set of propositions, a set of actuation actions, sensing actions, a formula describing the set of possible initial states, and the goal. Now, our propositions we can divide into the known propositions, okay, and the unknown propositions, where unknown means that there could be some point where it is unknown. So it doesn't necessarily have to be unknown the whole time, just at one particular point it might be unknown. So in the Wumpus problem, right, the location of the agent is known, and all the others are basically unknown, where there's stench, where there's a Wumpus, and whether some place is safe or not. So an actuation action consists of preconditions and a set of conditional effects. Okay, so it's a condition C and an effect E, meaning that if the action is applied and C holds, then effect E happens. And these are the movement actions and the Wumpus. And we also have a set of sensing actions which also have preconditions, and they observe an unknown proposition. In WUMPUS, we can smell something. So we need to be at location xy, and then we can check whether there is stench at location xy. So a complete solution is, again, a tree, right? You move right, then you smell. This is a sensing action, so you branch, and so on. The complete solution is much bigger than this, right? So conformant planning is a restricted case of contingent planning where there are no sensing actions. And what's nice about conformant planning is that the solution is a sequence of actions, okay? Now, another simple case of contingent planning is simple contingent problems. So what are simple contingent problems? This is where the unknown propositions are invariant, okay? And we don't have any actions which have a conditional effect that's conditional on an unknown proposition. So WUMPUS is simple because the WUMPI don't move, okay? And actions do not have conditional effects. Now, what's nice about simple contingent problems is that my knowledge always grows, or at least something that is known stays known, which is a really nice property. Okay. Now, there are some non-simple contingent problems like the rock sample domain, where basically we don't know whether a rock is good or not, and we have an action which activates a sensor, which checks whether they're good rocks in range, and that depends on the unknowns, meaning that this is non-simple. All right, so now let's move on to projections. So the classical projection of a conformant planning problem, okay, so now we're talking about conformant, is a classical planning problem where basically everything that is unknown we assume is false. And because we're making the assumption that preconditions are only positive, okay, which is not a really restrictive assumption, this classical projection is really a very pessimistic one. So in the case of WUMPUS, it looks like this, right? Basically, I can't go to any of the places where WUMPUS might be. But if you'll notice, I can go here, okay, because that's fine. So Bonnet and Geffner already showed this, right? And they showed that for simple conformant planning problems, the classical projection is sound and complete, meaning that the classical projection is solvable if and only if the conformant planning problem is solvable. Now, moving on to contingent planning, we have something called the simple weak projection. And now we need to basically take each of our propositions and define a three-valued variable. So which is just syntactic sugar for two propositions. P is known to be true and P is known to be false. Okay, so P might be known to be true, might be known to be false, and might be unknown. So we can take a contingent planning problem and create this mess of a thing. I'll go over these in a second. So what I want to show here is the initial state, which is basically what we know we put in the initial state, the value we know, and what's unknown we just initialize to unknown. Okay, so for each actuation action, we simply replace every occurrence of P, every positive occurrence of P with P star equals true, or P is known to be true, and every occurrence of not P with P is known to be false. Now, for the sensing actions, we do the same thing for the preconditions, plus for an action that senses P, we add a precondition that says that P is unknown, and then we basically create two actions, one which senses true and one which senses false, okay? We also add axioms to do some reasoning. So for an OR clause in my initial state, or my description of the possible initial states, I create an axiom which says that if m minus one of these disjuncts are known to be false, then the remaining one is known to be true. And for a one-of clause, I have the same thing, plus another one that says that if something is known to be true, then all the others are known to be false. So this allows me to do some limited reasoning. Now, this is basically the K-planner's projection, okay? And in simple contingent planning problems, this is sound and complete. Unfortunately, when you move beyond the simple problems, this is no longer sound and complete because this doesn't allow something that you know to become unknown, okay? So in order to fix that, we define something we call the weak projection, which basically adds some more effects. So if I have a conditional effect, Cp, and the value of C might be unknown, okay, then once I apply the action, I don't know what will be the value of P. This is how knowledge is lost in non-simple domains. So for every conditional effect which adds P, we add a conditional effect that says if C is unknown, and this is basically shorthand for if one of the literals in C is unknown, and P is known to be false, then P becomes unknown. And vice versa for not P, okay? Now, the weak projection is sound in general contingent planning problems. This is not as obvious as you might think it is. You can talk to Shlomi and Ronen to get more details or read the paper. Please don't ask me. Now you can ask me. Okay. Now we can also define the notion of of one projection being stronger than another, and that's basically what you imagine to be. Projection pi C1 is stronger than projection pi C2 if pi C1 can infer everything that pi C2 can. And in the paper we have a projection called the enhanced weak projection, which is stronger than the weak projection. It basically joins some observation and sensing actions in a pattern that is apparently quite common. But I won't go into the details here. Okay, so now how do we use these projections to actually solve contingent planning problems? So this is where the HCP planner comes in, and as you'll notice, it's very similar to the general FDP progress algorithm I showed you before. I don't think I called it that, but that's what we call it in the paper. So the difference is that the conformant planning is now done using the classical projection. Okay, so this becomes a much simpler problem. And we also choose a sensing action using a heuristic. And that heuristic is going to be based on landmarks, as I promised you in the beginning. So how do we get landmarks of a contingent planning problem? Well, what we do is we take the problem, compute the enhanced weak projection, which is a classical planning problem, and find the landmarks of that problem basically using your favorite landmark detection technique. We used Llama, everyone's favorite. So in simple contingent problems, this is sound, okay? So this is actually going to give you true landmarks of the contingent planning problem, something that must be true in every execution. In non-simple contingent problems, this is not always guaranteed to be the case, but our empirical results show that this is going to give you a good approximation, or at least this allows you to solve lots of problems. So what does a heuristic look like? Okay, so now we have a set of landmarks of the contingent planning problems. How are we doing on time? Oh, going really fast. Okay, so we're going to denote by R the set of achievable literals, and we're going to compute that using the delete relaxation on the projection. Okay, and for each reachable sensing observation action, okay, so now we want to choose an observation action, right? We want to choose the best observation action to sense, right? Or the one that will give us the most information, basically. So we're going to assume that our observation action senses true and denote the literals that are reachable by R+. And then we're going to assume that it senses false and denote what is reachable after that by R-. And then we're going to choose an action that maximizes the number of landmarks in R and R-, but not in R. So basically, the number of landmarks for which become achievable after I apply the sensing action. Okay? And we break ties by the number of reachable literals, again in R and R+ and R-, but not R, the number of reachable sensing actions, and the cost to apply that action. So in simple dead and free domains, our planner is sound and complete. Okay? In other domains, it's sound. Of course, I mean, how can you be not sound? You're just playing actions. But it's not complete. Okay? We can't guarantee that it will always find a solution. But we can show empirically that it solves a large number of problems. Okay, so here are the empirical results. Basically, we compared HCP to MPSR, SDR, CLG, and K-planner on a bunch of problems. And we ran each of these problems, how many times, Shlomi? A few times. These are averages. So we have the average number of actions and the average solution time. And as you'll see, most of the time HCP is fast and also cheap. Now, localize is one example where we can solve because our stronger projection is still not strong enough to do the inference needed for localize. Okay? Now, we also analyzed the effect of the individual components of the heuristic. So, oh, sorry. This is going the wrong direction. Okay. So, this is what you get on one problem, the WUMPUS 15, where when you use only the landmarks, right? Remember that the heuristic has a tie-breaking thing. So if you use only the landmarks, you basically get most of the performance that you get using landmarks plus the number of additional sensing actions plus the number of achievable literals plus cost. Okay? So the landmarks really give you the most information here, I would say. All right. So to conclude, we showed you an online contingent planner that relies on projections for heuristics, belief updating, and planning for subgoals. And we've also shown that landmarks are a useful notion in more than just classical planning. This is not the first work that does that, and probably not the last. So for future work, we want to see if we can find landmarks in non-simple contingent problems exactly, and we also want to do stronger projections. All right, thank you.
Yeah. I might have missed it, but when you choose the contingent, the sensing action to apply,
Yeah.
from my reading, it might happen the precondition is not actually achievable by a conformant plan. Is that correct or no? Do someone check this beforehand? Or?
So if
In principle, it's correct.
yeah.
So in principle, this could happen, but doesn't tend to.
It approximates the set of sensing actions that can be applied using the least relaxation.
Okay.
It may be wrong.
Okay. And you confused me a little bit. You said the landmarks are not sound for non-simple contingent problems, but on some other slide you said that the plan is actually sound.
The plan is a plan. It's a set of actions that you apply, and they're all applicable. The landmarks that you find are not necessarily landmarks of the contingent planning problem.
Moreover, defining a notion of landmark, you have to first define exactly what you mean in landmark.
Yes.
Or contingent planning.
That's also true.
Which is something that is, you might have different ways of defining that. So it's not even a well-defined statement itself.
Okay, great.
Other questions?
You say you're not complete, and that's fine, but for problems with dead ends, do you think the approach that you're taking actually helps you a little bit to avoid these sort of things?
I mean, it's hard to say.
Have you tried
So in general, online planners with dead ends are not a good match, right?
Right, and I'm just wondering if this is a little bit better match than what we've seen so far with the online planners.
Well, I mean, you can look at the empirical results and draw your conclusions. I would hate to generalize too much.
I think that we need a larger set of domains with more substantial landmarks to provide a good empirical evaluation of that. But I think that the fact that you are basing your choices on landmarks is at least telling you that you are progressing in a useful way towards things that are needed in order to achieve the goal.
Other questions? So I had a question. I don't know if I missed it, but you seem to say that you first look for if there's a conformant plan, you consider that to be the solution.
If they're to the goal.
Yeah,
Yes.
to the goal.
Yes.
So clearly you are assuming, I mean, there's a cost, there could be cost metrics where sensing is actually cheaper,
Yes.
and like the Bush-Iraq situation.
We are ignoring them completely.
Okay,
yes.
so then how many of your completeness and soundness issues will get affected? I mean, do you have any sense of, I mean, how serious is this bias
so
for finding conformant plans when they exist?
I would say in a domain with dead ends where you can reach the goal and you choose not to, I can't make any guarantees, right?
I think that's a question.
Oh, see, he got it. No, the question is that you have a conformant plan bias, so that basically, first bomb Iraq and then find out, instead of rather than finding out whether there are, things to be bombed.
That's a good
or not.
example.
And so the question is, so you could get wildly costly plans as against, so it's only about feasibility rather than about quality, right?
Yeah. Yeah.
Other questions? If not, let's thank Erez